Next, let's look at problem 33, which I have copied right here, which is, let's see, make sure I copied it right. 4 sine 3x cosine 4x equal to 2 sine 7x minus 2 sine x. And we're supposed to do, well, prove this is true, okay, all the time, regardless of what x might be. So to do that, well, how are we going to prove it? Let's look at this thing. This is sort of like a sine A cosine B. So let's find the formula and that fits this plan. So I looked for and found the product to sum formulas. Okay, one of these. So let's give that a try. I don't know, it might work, might not work. What was this? Sine A cosine B plan, or sine alpha cosine beta. So we'll follow this formula right here, okay, which equal to half of the sine of sum plus half of the sine of the difference. All right, so let's do that. And that would be equal to 4 times 1/2 sine of the sum times sine of these two together, which is 7x, and then plus sine of the difference. The first one minus the second one, this one minus that one, that will be minus x. So when we put this together, that becomes, multiply everything out, it becomes 4 times half, that's 2 times sine 7x, that will be 2 times sine of 7x. And next is 2 times this thing, and the minus sign comes out of the sine because sine is odd. Okay, and sine is odd because only cosine is even. All the other two are all odd. And then secant is even just because it's 1 over cosine, and the others are all odd. So anyway, so being that it's odd, this negative sign comes out. So this becomes minus 2 sine x, the 2 coming from the 4 times 1/2 over there. So yeah, so that's exactly what it says. So we got another problem done. So that's problem 33. Next. So next, let's look at problem 34, which is 6 cosine 8x sine 2x divided by sine of negative 6x. And we're supposed to prove that equals to minus 3 sine of 10x cosecant of 6x plus 3. All right, let's see. Okay, so, well, what formula are we going to use? I guess we're just going to use the product to something again, because there's a product here, so let's do something with it and hope that something good comes of it. So this is cosine times sine, and so we'll use the exact same formula we just used. That is the one that says, let's see, the sine and cosine one, okay, so that is sine alpha cosine beta equals to 1/2 sine of alpha plus beta plus sine of alpha minus beta. And then, so these two, Anyway, so let's write that down and see what happens. So we have 6 times, and the one is sine alpha cosine beta, so it equals to 1/2 of the sum and then plus 1 plus the difference. So times 1/2. First we'll do the sum with sine. What's the sum? A plus 2 is 10x, and then plus the difference, sine of the difference is the one in front of the sine is doing the subtraction. This is alpha, okay, because it says sine alpha cosine beta. That's important. Being that the formula states sine alpha cosine beta, so, and then it's sine alpha minus beta, this will be alpha, so it's 2x minus 8x. So 2x, what am I doing? 2x minus 8x, that is negative 6x. So let's just write that and call it that. So minus 6x. And then this thing is in parentheses, so this multiplies throughout. And that would be equal, and that divided by sine of minus 6x. Okay, so that would be equal to, so that equals to, let's cancel this out, okay, that becomes 3, right? And then we'll multiply this out, so that will be 3 sine of 10x there's an x here, divided by minus sine of 6x, okay? And that's this part of the fraction. I'm breaking up the fraction here. And then the other part is plus 3 times, here's a 3 times sine negative 6x divided by sine negative 6x. That is just 1. 1 times 3 is 3. So we have a 3 here. And this is exactly that, because sine dividing by sine of 6x is the same as cosecant of 6x, because cosecant is 1 over sine. Okay, so then let's see, maybe I should move this over a little more so you can see better. There. All right, so then this is exactly that equation, and so we're done. Now notice how this cancels out with this when you break it into 2 fractions, but you still have the 3 over there. Okay, so don't forget the 3, which is also over here, so then everything works out. So that is problem 34. Next. So next, let's look at problem 35. We have sine x plus sine 3x equal to 4 sine x, and then cosine squared x. Okay, so there's a square here, so we can't pull the same trick that we did the last 2 times. See, the last 2 times we just used the same formula, and it lucked up, and everything worked out okay, I mean quickly. But this one, because of the square here, we can't use that same formula, so we need to come up with a different trick. Let me think what kind of trick I'm going to come up with. So I'm looking at our formulas here, and I think the closest formula, let's pick the sum to product formulas. That is, we'll do the sine alpha plus sine beta equals to 2 times sine of alpha plus beta over 2 times cosine of alpha minus beta over 2. We'll call this alpha and that beta. Okay, and then see what happens. I don't know if that's going to work, but we'll give it a try. As well, let's do something. So then sine alpha plus sine beta, so that's alpha plus beta, and by the formula, so then the left hand side, that is this thing, is equal to 2 times sine of alpha plus beta over 2. So x plus 3x over 2, that should give us 2x, times cosine of alpha minus beta over 2. So then x minus 3x, that's negative 2x over 2, that's just x. And cosine is actually negative x, but cosine is the even function. Okay, so if there's a negative sign inside, you can just throw it away. So now I got this thing. Yeah. All right, so that gives us 2 sine 2x times cosine x. That doesn't look quite like that. It's close, but not good enough. So let's turn the sine 2x then into something. What is sine 2x? Now the double angle formula sine 2x, sine 2 theta here, is sine 2 theta is equal to 2 sine theta cosine theta. So let's write that down. So this equal to 2 times sine 2x equals to 2 sine x cosine x. That is based on the formula I just showed you, okay? Because sine 2 theta is 2 sine theta cosine theta. So just the sine 2 theta here is 2 sine theta cosine theta, and there's an extra 2 that I just left out there. So we have 2 2's. And then the other side is cosine x. Now things are looking much better. See, this is 2 times 2 is 4. 4 sine x, then cosine x squared. So that is the answer, and we are done. Right. Well, in the class, you probably want to finish writing the last line, but I don't want to bother. Okay, so I'll stop right here. So next, let's look at problem 36, where we have 2 times cosine cubed x. That means cosine x is, the whole thing is being raised to the power 3, minus cosine x sine squared x equal to cosine of 3x plus cosine x. All right, so then what are we supposed to do here? Well, I don't know. So let's, but there is a common factor here. So when we don't know what to do, let's factor something out and see if anything good comes of it. So we'll have 2 cosine x, okay, I factor 1 cosine out. So we have cosine squared x minus sine squared x and that is the top side. Now cosine squared x minus sine squared x sounds familiar. So when we look into the pack of formulas, when we look into the pack of formulas, then I notice that that phrase, the cosine squared x minus sine squared x, is actually in the double angle formulas for cosine 2 theta. See, it's one of the formulas for that. That is cosine squared theta minus sine squared theta equals the cosine of 2 theta. So let's plug that in and see if anything good come of it. So this equal to 2 times cosine of x and then times cosine of 2x. Based on that formula. Okay, so that is that's fine. And so next, but that is still not what we're shooting for, right? We're going for something like that. So this is a product, and so this is a product, and that is some kind of a sum. So suppose we can do that sum and product business. And what are we doing? We're turning a product into a sum. All right, so let's do that. So let's look at, and this is a cosine x and then cosine 2x being multiplied together. That's the product. So let's look at a product to sum formula. There's cosine alpha, cosine beta. Okay, it's just similar to this. So alpha will be x and beta will be 2x. So let's look at the formula again. Cosine alpha cosine beta equals to 1/2 cosine alpha minus beta and plus cosine of alpha plus beta. So let's write that down. This is equal to 2 times 1/2 times, what was it? Cosine of one minus the other. So it's cosine of x minus 2x. That would be just x, because it'd be negative x and we'll throw away the negative sign. And then because cosine is even, plus cosine of alpha plus beta plus cosine of alpha plus beta, that will be 3x, and we'll write that down. Okay, so the 1, 2 and 1/2 cancels out, so we can ignore them. So we end up with cosine 3x plus cosine x, and that's exactly the right answer. So we are done with problem 36. Next, after I clean the board. So next, let's consider problem 37, which is, I was holding the wrong tablet. 37 says 2 tangent x cosine 3x equal to secant x sine of 4x minus sine of 2x. So we need to show that this is true. This looks like a product, right? It's a tangent x times cosine 3x. The only problem is we don't have any formula that has to do with tangent times cosine. There's only cosine times sine or sine times cosine, that sort of thing. Cosine alpha, cosine beta. Well, whatever. The point is we don't have anything to do with tangent. So we can write tangent as sine and cosine, see if we can get somewhere. So the left-hand side, we'll again start at left-hand side. All right, the left-hand side is equal to 2 times tangent. We'll write the tangent in terms of sine and cosine, which will be sine x over cosine x, which is tangent x. Okay, opposite divided by adjacent, right? And then times cosine of 3x. Now remember, this cannot cancel out. Cosine 3x is completely different from cosine x, and you can't factor out the 3 either. So, don't try it. Anyway, so it equals to this, and at this point, however, we can apply this product to something to just this part. So let's do that. That is, we can apply the product to some formula. What is this again? Sine alpha cosine beta. So we'll use this formula right here. The sine alpha cosine beta. Yeah, the sine alpha cosine beta formula, where x will be alpha and beta will be 3x. So that would be applying that formula. We have 2 over cosine x, which is here. Okay, and then the inside we have what is the formula? It equals to 1/2 times sine of alpha plus beta, and so okay, so that would be sine of x plus 3x, which is 4x. So that's so far so good. And then plus sine of alpha minus beta. So again, this is alpha and that's beta. So x minus 3x, that gives us sine of minus 2x. And for sine, the negative sign has to go to the front. So then our result then is the 2 then cancels out. We can ignore the 2. And so the result is 1 over cosine is secant. Okay, remember this thing right here? The secant is 1 over cosine. So 1 over cosine is secant. And then here's sine 4 of x. And then this minus sign comes out. So it's right here. And sine 2 of x. So that is done proving. And we are done with problem 37. See, this is exactly that. Next. Okay, next let's look at problem 38, which is cosine of a plus b plus cosine of a minus b equals to 2 cosine a cosine b. I think we already did this. I mean, the book already did this. So that just used the original sum difference formulas. That is right here. Okay, I have this is cosine of a plus b is this thing right here, right? Cosine of a minus b is this thing right here. If you pretend that alpha is a and beta is b, well, alpha is a in Greek and beta is b in Greek, so it all works out. So if we add, what are we doing? We're adding them. If we add these things together right here, then right here the sine alpha sine beta cancels out. So what we're left is 2 times cosine alpha cosine beta. See, there's 2 of them left. That's it. That's the proof of problem 38. Next. Okay, now problem 45, we have this thing. We have to figure out what does it equal to, okay, in terms of identities. So let's, first let me check that I wrote down the problem correctly. Cosine 10 theta plus cosine 6 theta over cosine 6 theta minus cosine 10 theta. Okay, that should be good enough. And let's look for a formula that matches it. That looks like some kind of a sum. Do we have any sum formulas? Yes, we do. Here it is. What are we doing? Cosine sum formulas. Okay, so we'll do the plus and the minus of the cosine sum formulas right here. Okay, sum to product formulas. Cosine of alpha plus b is 2 times cosine of the sum over 2, and then times cosine of the difference over 2. So let's write that down for just the top, following that formula. That would be, so this equals to, the top is the sum formula that equals to 2 times cosine of the 2 of them added up. That will be 16 theta, and then times cosine of their difference. That will be 10 minus 6, that's 4 theta. Okay, the sign doesn't matter. If there's a negative sign here, we'll just trash it. So that is 16. Wait a second. Did I get it right? It's 10 plus 6, 16 over 2. I forgot to divide by 2. Because the formula says it's alpha plus beta, right? But divided by 2. And I forgot to do that. So let's do that. And alpha plus beta divided by 2. So it's not 16. There's only 8. So write down the 8. And the other one is alpha minus beta is 4. But we have to divide it by 2. So there's only 2 in here. Here we go. So that's the top, and then the bottom then becomes cosine 6 theta minus cosine 10 theta. It's the cosine alpha minus cosine beta situation. And that has to be equal to minus 2 times sine of the sum and then sine of the difference. Okay, and this is alpha. Okay, the first one doing subtraction is the alpha. All right, so let's follow that rule. So that it will be minus 2 times sine of alpha plus beta, and so 6 theta plus 10 theta divided by 2, that's 8 theta, and then sine of alpha minus beta, and this one is alpha. Okay, so 6 minus 10, that's minus 4 and minus 2 theta. Now at this point, the negative sign has to come out in the front. And so, yeah, so then we'll cancel out with this one, and then cancel out the 2. And we have something like that left. And what is that? Anyway, so that is cosine 8 theta over sine 8 theta. Cosine over sine is 1 over tangent, right? 1 over tangent is the cotangent. See, 1 over tangent is the cotangent. So this is equal to cotangent of 8 theta times, similarly here, this is cotangent because it's tangent being flipped around. So cotangent of 2 theta. And that is, I believe, the other side, right? Is yes, it is. See, cosine 2 theta, and then cotangent 2 theta times cotangent 8 theta right here. So this equals to the left hand side does equal to the right hand side, and therefore this is indeed an identity. Because this problem asks us, is it an identity? Yes, no. It's a yes, no question. So the answer is yes, and that is problem 45. So next, let me see what to do next. Oh, before I move on, I should show you something that I forgot to show you last time. This is in the previous section. Okay, there was a homework problem number 51 where you're supposed to graph the function and graph the one side of the identity and graph the other side to make sure that they are the same. So I graphed it on Desmos, and here's how you type it in. Okay, I mean cosine squared 2x, you can type it in just like it says, just cosine squared 2x times sine x, and look at that. They are identical, aren't they? They just and they look pretty nice too. But anyway, yeah, so I forgot to show that to you. And this, the next problem we're doing also have a graphing requirement, which I forgot to do. But you can just graph it similar to the previous one, and that should come out okay. So anyway, so next let's look at problem 51, which is sine of 3x minus sine of x, and then divided by sine of x. All right, so what does that equal? We will, considering that fact, then let's look at the formulas and see if there's any formula that fit this. Okay, we have a pack of formulas, but does any one of them, oh no, this is the wrong formula, but it might work out anyway. Yeah, it does. Okay, I looked at my old formula, which is all right. Anyway, so let's do this one right here, where we have sine alpha minus sine alpha minus sine beta, which equals to 2 times sine of the difference and then cosine of the sum. All right, so let's do that. Following that plan, we have sine of 3x minus sine of x. This will be the alpha, and that will be the beta, and that equals to, we'll write down 1 over sine x outside, so that is out of the way. And then and then the numerator we have 2 times sine of is sine alpha minus sine beta. Okay, so 2 times sine of alpha minus beta. Okay, so it's 2x, and then divide by 2, so it's just sine x. So 2 times sine x, and then the next thing is and then cosine of alpha plus beta. Okay, cosine of alpha plus beta divided by 2. That will be 3 plus 1, and then divide by 2. That's 2x. Okay, and then if we cancel out one of the sine x's, then the answer is 2 times cosine 2x. And the answer at the back of the book says I'm right. Okay, so next. Well, turns out it's almost midnight again, so I will finish this section in the next video.